Well, John already thanked everyone for spending the time, but I'm still like left behind. So I'm the last one between you and the drinks. I hate to do that. Okay, one more? Okay, good. So my name is Chloe Ma. I'm actually responsible for cloud marketing at Mellanox. And I'm here on behalf of my coworker, Scott Schultz, who is on the technical steering committee for OpenPOWER. A lot of you probably know Scott already. So I'm here to represent Mellanox to talk about how we can get your application performance and scalability to a whole new level through Mellanox Smart Interconnect. So I grew up in China. In the late 1970s and 80s, China had a slogan. So basically they said by the year 2000, we're going to realize 4 modernization. And that's agricultural, industrial, defense, and science and technology. So we talked about it every day, but it felt so far away because it's like still 15 years. But by the time we knew it, year 2000 has come and gone. And similarly, 100G BPS, it's something that we talked about and dreamed about. And as of last year, Mellanox has announced our end-to-end 100G solution. And the future is really here. And we're seeing very healthy adoption of our 100G technology, not only in high-performance computing, but also in our hyperscale customers, the cloud and internet companies like Microsoft, et cetera, et cetera. And we're also seeing adoption expanding to the smaller and more nimble cloud and high-performance scientific cloud providers. So why do what's motivating us to go for 100 Gbps? It's because we're actually generating a lot of data. According to the then Google CEO, Eric Schmidt. So Eric Schmidt said in 2010 that the amount of data that we generate in 2 days back then is equivalent to everything that we generated up till 2003. So fast forward now, till now, we're generating even more data. And static data actually has little value. So only when you crunch the data and analyze them and really derive insights, the data is very useful. So in order to do any data analytics, you pretty much need to move the data. And at Mellanox, we enable the fastest data movement. And to push science and technology to the next level, to the new frontier, we really need computing power that's 500 to 1,000 times more capable than today's supercomputer. And what we have done so far is going from SMP to a clustered architecture from single core to multi-core. But to really push performance to the next level, doing the same thing just doesn't cut it anymore. We really need a culture change. So that's what we call the co-design. So I think there is a famous venture capitalist from Andreessen Horowitz, Mark Andreessen. He said something famous in 2011. He said, software is eating the world. And fast forward a few years, this phrase is updated. Do you guys know what's appended to that? So it's software is eating the world, but open source is chewing it up. So basically, if you look at some of the most innovative software development area, it's pretty much all software, all open source based, like OpenStack, like containers and Docker, etc. So the open source, open design mindset can really inspire collaboration and innovation from all sorts of players, not only in the hardware ecosystem, but also in software, and from the industry to the vendors and to the users. So at Mellanox, we are a loyal member of OpenPOWER, because OpenPOWER really aligns with what we believe. So we believe in openness, open standard, open API, open source, open design. And that's how you can really promote more innovation. And OpenPOWER actually proved it. And because of the open development and the collaboration, we actually get much higher performance on power architecture. And the co-design mindset, how can it help us break the application latency wall? How can we shorten the latency? If we look at what happened in the last 10 years, the interconnect latency has been reduced from around tenths of microsecond to about 0.1 microsecond. And it used to represent about 10% of the overall communication framework latency. But now, because interconnect is getting faster and faster because of technological advancement, it's only representing a very small portion, about 1% of the overall communication framework latency. But going forward, I mean, right now we only have 0.1 microsecond. If Mellanox work ourselves to death, we cut that number to 0, it won't make a big impact. So the solution, the answer is really in code design. So how can we move some of the functionality from for example, the CPU to the interconnect, and do things more efficiently? So I have just to give an analogy, I had a coworker, so I'm from the San Francisco Bay Area. I had a coworker who lives in Santa Cruz. And to commute to Silicon Valley is about an hour each way. And in the pre-2007 days, that's pre-iPhone days, it was a torture for him because he couldn't really do anything while he was driving. And he went through all the audiobooks that he likes in 4 years. And then he quit and found a job locally in Santa Cruz because he just couldn't take it anymore. But in 2007 and onward, the smartphone got connected and got created. So as of 2010, he returned back to Silicon Valley working for Google. And now he takes a bus, a shuttle from Santa Cruz to Google campus. So on the bus itself, he could actually do a lot of work because they have Wi-Fi and everything. So similarly, if you can actually do a lot of the processing work when you're moving the data, first, it's more efficient, and second, you can move less data in this process. So this is just a picture illustrating that we need more smarts and intelligence in the interconnect itself to be able to get us to the next level. So this is ConnectX-5 is our next generation NIC card. So it supports the CAPI architecture that Bruce talked about. And this greatly simplifies the memory management between the CPU and the coprocessor and the interconnect. And also, it provides a new level of integration that removes additional latency. And so we could actually support collective offload in the NIC so that the collective offload can happen for all the workloads in the same host. And next, we're actually going to introduce our next generation switch. So this is also the world's first smart switch. So instead of just doing the collective type of offload in the NIC itself, we can actually do that in the switch, so that even if you're collecting results and data from multiple nodes, you can still finish the collective offload before it hits the head node. And this is the name of the technology that supports this kind of offload. It's called SHARP, the Scalable Hierarchical Aggregation Protocol. So the effect is actually very obvious. By offloading the MPI operations from the CPU itself to the network, we actually can deliver more than 10 times of the performance. So this is one of the benchmarks, the mini FE benchmark. We're comparing the latency of CPU-based MPI approach to more of a SHARP-based approach. So at 32-node cluster, the difference is about tenfold. So the latency of CPU-based is about tenfold of the smart collective offload that's offered by Mellanox. And when we grow the cluster to about 8K nodes, the effect is more pronounced. So we're seeing about 25 times difference in terms of latency. So this is just another set of benchmark, the OpenPOWER application. We are seeing about 2.2 times of improvement in terms of latency. So how many of you actually know that Mellanox also does Ethernet switches instead of? Okay, great. So basically, like, I think we did such a good job in high-performance computing and InfiniBand that most of the people still believe we are an InfiniBand company. But our Ethernet business is actually the fastest growing sector because we're selling to a lot of the hyperscale players. And this is our latest Ethernet switch that supports any port speed from 10 to 25, 40, 50, up to 100. So it's actually on par with what we could offer on InfiniBand. And also, in the beginning, I talked about Mellanox is a big believer of openness. And in our hyperscale customers, we see that they are doing a lot of infrastructure disaggregation. And in terms of networking, they actually want to disaggregate the switch operating system from the switch hardware itself. So they can either write their own switch operating system to maintain the consistency, or they could actually select from multiple switch operating system software vendors. So at Mellanox, we support Open Ethernet. So basically, on our Spectrum switch, we can actually run multiple switch operating systems. We can run, for example, the Azure, it's called Sonic. So basically, it's a switch operating system that's used in Microsoft Azure. We can also run Cumulus Linux. We can run our own Mellanox OS. We can run HP, it's called Open Switch, et cetera, et cetera. So aside from the great performance that we can provide, we also provide you the greatest flexibility. And in terms of upgrading from your existing 10G to 25G, from your 10G downlink, 40G uplink, to 25G downlink, 100G uplink, basically 2.5 times of the performance, you actually don't need any cable changes. It's a very easy upgrade. So as a summary, we are a strong supporter of OpenPOWER because we believe that only the open ecosystem can inspire innovations and to meet our customers' need. And we believe that the intelligence to really get us to the next level in terms of boosting application performance and scalability, we need a co-design approach and move more intelligence to the interconnect, to the coprocessor, etc. Thank you, everyone.